Today we're doing verifying identities, day 2. So we're going to get more involved with our identities. So for all of these, you should have your list of identities that you copied down yesterday from the video to kind of help you understand where we're going with these. So here I have cosine of x minus cosine of x times sine squared of x. And I'm trying to prove that this is equal to cosine cubed. So the first common mistake is that students look at this and say, they ask if they can do cosine minus cosine and cancel that out. You cannot do that because this cosine right here is attached to the sine squared. They're one whole term, so you cannot subtract them. What you can do, however, is factor out your greatest common factor. So notice this term and my second term both have a cosine in common. So I'm going to factor that cosine out front. And by doing that, I'm left with 1 minus sine squared of x. And I'm just going to write off to the side a fact real quick. So I want you to recall that sine squared plus cosine squared, I'm going to run out of room, hold on. So sine squared of x plus cosine squared of x is equal to 1. So if I were to manipulate this identity, and I would get cosine squared by itself, I would subtract this sine squared over from both sides. So they would cancel, and I'm left with cosine squared of x is equal to 1 minus sine squared of x. So I need to use this fact right here in my problem. So I'm able to replace 1 minus sine squared with cosine squared. So now my problem will say cosine of x times the quantity of cosine squared of x. And cosine times the cosine squared of x is equal to cosine cubed of x. And notice we have now verified our identity. So we will do more practice tomorrow of problems with sine squared plus cosine squared equal to 1, where we have to manipulate the identity. So for our next example, I have 1 plus sine of x all over cosine, and I'm trying to prove that this is equal to secant of x plus tangent of x. So I want you to notice on the right-hand side that I have two separate terms, and they're separated by a plus sign. So I need to go over here, and I need to split this up into two terms. So my first step would say 1 over cosine of x plus sine of x over cosine of x. And really you have to kind of think, as far as strategy goes, everything was already in terms of sine and cosine. So I didn't really have much of an option here. Now that I've separated, everything is in terms of sine and cosine. I want to kind of look over here and see what I'm trying to prove. So 1 over cosine of x, that's going to give me my secant of x. And sine of x over cosine of x gives me my tangent of x. So at this point, we've now proved and verified that our two sides are equal. So we have one more example. So here we have sine squared of x times the quantity of 1 plus cotangent squared of x. And I'm trying to prove that this is equal to 1. So I'm going to do this problem two different ways. So I again can kind of show you that you can do these problems multiple different ways and still get the final answer of 1 and go about it differently. So for the first approach, I'm going to say that I want to distribute this value of sine squared in. So sine squared of x times 1 will give me sine squared of x. Then I have sine squared of x plus or times cotangent squared of x. So I simply distribute it in. Now I want to get everything in terms of sine and cosine. So just a quick recall down here. I know cotangent is cosine of x over sine of x. So if it's cotangent squared, I just make everything squared, and I can use that identity. So I have sine squared of x plus sine squared of x times cosine squared of x over sine squared of x. And now I want to put these two fractions together, and when I multiply, I just multiply straight through top, straight through bottom. So I have sine squared cosine squared all over a sine squared. And notice I have a sine squared on the top and the bottom, so I can reduce this whole thing by a sine squared. They're going to cancel out. So now I'm at sine squared of x plus cosine squared of x. And I know a sine squared of x plus cosine squared of x is equal to 1 using my Pythagorean identities. So I've now proved this theorem. So I'm going to do this same problem one more time just to show you a different way. So again, I have sine squared of x times the quantity of 1 plus cotangent squared of x equals 1. And some of you might be thinking, well, I was looking at my Pythagorean identities and I noticed that 1 plus cotangent squared of x is equal to cosecant squared. And you are right, so I can replace that with cosecant squared. So I have a sine squared of x times a cosecant squared of x. And using my reciprocal identities, I know that cosecant of x is the same thing as saying 1 over sine of x. So that means cosecant squared is the same thing as saying 1 over sine squared. So this will become 1 over sine squared. And now when I multiply my fractions together, I multiply my tops and my bottoms, and I get sine squared of x over a sine squared of x. And this is going to completely cancel out to be 1. And again, I verified my identity. So, again, two different ways to do the same problem. Just so you kind of go with whatever way makes sense to you. So that's all for today.